DIOPSIS camera is an advanced modern system to photograph, recognize, and monitor insects in a fully automated manner. It is created by Fornabit in the Netherlands. The camera has been designed to allow for continuous measuring throughout several days or even weeks, without any need to physically visit the camera. The AI algorithm behind the camera, developed by Naturalis, can count insects, calculate insect biomass, and has the long-term goal to identify all the insects in each photo to species level. Insects are attracted to the yellow screen and trigger the camera to take a photograph anytime they land on the screen. The camera is able to take pictures during the day and the night whenever insect motion is detected. In order to photograph in the dark, LED lights are built into the camera. Once taken, the photos are sent to an online server via 4GAS, as well as being stored on the local SD card. You can use the DIOPSIS app and website to follow the real-time feed and status of the DIOPSIS camera in the field. Make an account in the DIOPSIS app and log in with your email address and password. After logging in, you will see 3 tabs: Research Projects, Data, and Cameras. In the Cameras tab, you will find all the cameras that Fornabit has granted you access to. The only way to be able to view camera data is by first asking permission from Fornabit. After permission is granted, you can find all the general information about the camera, like the camera name, the current research project, the location, the period, and the GPS location. In the column Status, you can see whether the camera is working or not. Further in the video, we will explain more about this feature. In the column Actions, you can find the Activate Focus mode, in which you can find the real-time photographs to focus the camera. See later in this video for more information as well. In the Research Projects tab, you can add new projects to which you want to attach the data. By clicking the plus sign in the top left-hand corner, you can add a new project to the Research Projects tab. You can then associate camera data with this project. You need to give the project a name, a description, and a start and end date. Research projects can always be edited later via the Settings and Edit Research buttons. Within the research project, if you click the big plus sign, you can add a new research location. First, fill in the general box. This includes the name of the project, the camera you want to use for the project. You need to give the location a name and select the exact start dates and times, as well as the end dates and times of when the specific camera will be deployed. Note, this start and end date has to fit within the dates of the research project. This is important because the data will later be separated by the timeframes per research project. Inside the yellow sensor box, click whether the yellow screen is positioned vertically or horizontally, and whether the legs are unfolded or folded. For the location box, tap the camera location to use the GPS in the camera when it is set up. It is possible to locate the camera via one of the other given options, but the camera location is the most accurate way to do this. Click Save. You will now see your added research location within the chosen research project. Under the Data tab, you will find all the data linked to your account. At the top of the page, you can choose your data selection frame. So which camera do you want to see the data from? Within the selected time frame and camera, you can then find all the data in the form of the photographs, as well as graphical visualizations of the data and battery level. The DIOPSIS camera system comes with an 8 megapixel camera with an associated camera number. It has an LED backlight, internet modem with SIM card for online storage, and a USB flash drive for local storage, as well as a GPS tracker to locate the camera when out in the field. The camera is found within a stainless steel casing for protection, which comes with a case number corresponding to the camera number, It has 4 foldable steel legs to allow for different heights of the camera when in the field. There is a foldable yellow insect screen attached to the steel casing, which is used to attract insects to the camera. Inside the casing, there is a waterproof battery case including tension strap. Inside that is a 12-volt 20 ampere hour battery to store electricity between the solar panel and the camera. And finally, there is a 12-volt solar panel which generates electricity for the camera. The first step in setting up the DIOPSIS camera is to make the necessary connections within the camera. First, by inserting the internet modem, which already has the SIM card inside. Then, inserting the USB flash drive and GPS tracker. It does not matter which stick is inserted into which USB port. However, it makes sense to make a logical choice based on the space available inside the camera. The next step is to set up the steel casing. First, unfold the legs. Make sure they click into the buttons on the steel casing. This will ensure optimal stability when out in the field. Then, open the steel casing with the clip at the backside. Make sure the yellow screen folds down in a horizontal position. The yellow screen should always point southwards. Next, install the camera vertically to the casing using the rotary knob. Aim for an approximately 30 cm distance between the lowest part of the camera and the yellow screen. We can ensure the exact distance later using the app. Make sure to carry the black cable from the camera through one of the gaps in the casing. Open the black waterproof battery box and place the battery to one side. Make sure the battery is not resting on the cable. Once the battery is in the box, attach the battery cable to the camera cable carefully. Secure the cables extra firmly to ensure that the cable is waterproof. The camera is now working. Next, we will set up the solar panel. First, take the solar panel out of the bag and open it by releasing the clips. The solar panel should be placed on the ground, ideally about 1 to 2 meters from the DIOPSIS camera. The solar panel should be pointing towards the south. Make sure the solar panel will point upwards by unfolding the legs. Next, attach the cable of the solar panel to the battery by clipping the battery clamps found at the end of the cable directly to the battery. Make sure that the colors match with the battery poles, red to red and blue to blue, and that the grey box is inside the waterproof black box. The solar panel will now charge the battery. Close the black waterproof box, making sure that the grey box is inside the waterproof black box and that the cables are not squeezed. To ensure that high-quality in-focus images are taken, the distance between the camera and the yellow screen most likely has to be adjusted. The camera can be adjusted by unscrewing the knob on the slider and moving the camera up or down until the right distance is set. The right distance can be determined by looking at the real-time focus photos on the app. The real-time focus photos can be found by opening the DIOPSIS app. Navigate to the Cameras tab and then to the camera in question. Click on the Activate Focus Mode button in the Actions column. Press play and wait for the photograph to appear. This can take some time depending on the internet connection. The distance is correct when the camera is at its highest distance from the yellow insect screen before showing any background visuals at the side. Once this is fixed, the camera is ready for use. To make sure the camera is working as it should, you can check on the website. Click Cameras and look at the Status column. In this column, you will find 3 icons per camera: last connection, last sensor data, and last photo. If the camera is fully operational, these 3 icons should be green. The other colors all indicate a temporary defect. An orange icon means that it is still working, however there is a delay in the internet connection. If an icon is red, you should keep an eye on it. The camera will either come back online soon or will fail permanently. A grey icon should ring alarm bells, as this means the camera is not working properly anymore. The 3 different icons can have each of the 3 different colors as well, depending on the problem. In the Data tab, you can find a graph with the battery levels to make sure the camera has enough energy to work properly. In case an icon stays red for too long or turns grey, the best option is to restart the camera. To restart the camera, you need to disconnect the cable between the camera and the battery. After doing so, wait about 30 seconds before reconnecting the cables. This reset will work most of the time. In case the icons are turning red or grey soon after reconnecting, please contact Fornabit at info@fornabit.eu or by phone. After the fieldwork at a particular location is complete, it's time to clean and pack the DIOPSIS camera. The first thing to do is disconnect the cable between the camera and the battery, as this prevents the camera from taking photos while packing and cleaning. This moment is also the best time to clean the DIOPSIS camera. For optimal camera operation next time, you should clean at least the yellow screen, the camera lens, and the solar panel with water and soap. Make sure to dry after cleaning. After this, you can detach the camera, take out the USB flash drive for internal storage, and place the camera inside the casing. Next, it is time to pack away the solar panel. First, make sure the battery clamps have been removed from the battery, and then roll up the cable neatly and place it inside the solar panel and fold it. Make sure the cable isn't squeezed while folding the solar panel. Place the solar panel back in the bag and close the black waterproof box inside the casing. You can leave the battery inside. Finally, you need to close the casing and make sure that the clip at the backside clicks into place. Now, fold the legs of the casing to the side so that they fit nicely together. The camera is now ready to be moved to your next research location. To extract and analyze data from the DIOPSIS portal, you need to have an account on the DIOPSIS portal and have access to the Arise collaboration via SURF. You will need accounts to be set up on the DIOPSIS website, the SURF Research Access Management, and the Arise portal. Please see documents for details. Once the account is fully set up, you will be able to see the dashboard in Arise, which currently shows recent analysis jobs that were performed. From here, we will go step by step through all the requirements needed to obtain your data from the cameras. This will work via the functions that are visible in the panel on the left. Along the side of the screen, there is a series of different options. Selecting Sensors will give you an overview of all the cameras that are available to you and the information of where they've been located. Clicking on Ontologies will give you an overview of the different annotation options. So for example, when pictures are unusable because a photo is very blurry or there are raindrops visible, you can annotate them with this information for later knowledge. Clicking on Media Browser is where we really begin to analyze the data. Here we can select our photos and combine them into a dataset. To select the photos we want, we can add all kinds of filters using the Add Filter button. For example, we can select for a certain sensor, camera, and tell the portal from which period in time we need the data using the Capture On filter. With the Capture On filter, you can select the time frame in which you use the camera for your project. You can also select Deployment, which gives you all the photos from a specific plot or experiment. The media browser now displays a list of photos. You can click on a couple of them to get an idea of what the photos look like and to see what kind of invertebrates were recognized within that photo.
On top of the media browser, we see Total Selected. This number tells us how many pictures are available in the database given the filters that we added. If you have filtered the dataset to your requirements, you can now click on the Create Dataset button in the top right-hand corner. Your newly created dataset should now be visible under the Dataset button in the bar on the left side of the screen. The Algorithm button below will give you an overview of the different AI algorithms that can be used to analyze your photos. Next, we want to click the Start Analysis function, which gives us 3 options. Under Algorithm, you select the AI algorithm you want to analyze your data. In this case, we're using the DIOPSIS inference server. Under Dataset, select the dataset that was created in the previous steps. These 2 variables together create the job name, which you can adjust to your needs. And now, if you are ready, you can click on Start Analysis and the photo analysis will start running. You will be able to follow the progress of your analysis under the Analysis Jobs button, the last button on the left side of the screen. It's possible that the analysis can take a long time, depending on the size of your dataset. The status column tells us how the analysis is progressing. If the status tells us it's completed, the dataset is ready to download. Click on the 3 right dots on the right-hand side and select Download CSV Results. You will now receive your final results.